I know that there's nobody on right now. No, that's just me. I know that there's nobody on right now, so I wanted to go ahead and record this session since I missed being able to be with you guys last week and see if I can make sure that we catch up to where we need to be. I did grade week 2's discussion board and your assignments. Those are in Canvas graded. Yeah, everybody did wonderfully. That's really good. I'm going to start with week 3. We'll go over pieces of things that we need to worry about. And then I'm going to see how much of week 4 I can cover. What I will do next week when we get together for week 5, we will finish up whatever I missed of 4. Then I will give you the opportunity to do your midterm in class, and we'll make sure that it works so that you don't miss out on anything. Week 4 normally is not a really long week. It's only 2 chapters and it's not too bad. So I think we're going to be okay. But we'll go through it a piece at a time, and we'll make sure that you get what you need so that you're getting out of the course what you need. As I normally do, let's review at the very beginning some of the vocabulary from prior chapters. Now we are actually, when I did the online review last time, I actually went through chapter 6. I did have it mismarked on my notes. There's one. Yay.
Hey.
How are you?
I'm okay. How are you?
I'm doing wonderfully.
I'm so sorry.
What I was saying, I'm recording this session just so you're aware.
Okay.
That's so you guys can all review it later because we're trying to play catch up, and I don't want you to miss anything. Okay. And anybody that couldn't come online at this time would have that opportunity. So just a heads up that I am recording it. So no tantrums on how bad stats is. I did say that everybody did really good in this week 2 assignments. I did get those graded, and I did get the discussion boards graded. And I have to say the 3 of you all picked out really good examples of correlation that is not cause and effect. And a lot of times people still have a confusion between correlation and cause and effect. Pandemic is a real good example of correlation, but not necessarily cause and effect. Pandemic is responsible for if you get sick and there's a problem. But it may not, it's a correlation between some of the mental health issues. It doesn't cause the mental health issues, but circumstances surrounding it contributed to it. The other one was, let's see, we looked at the pandemic and suicide. I'm trying to remember them. And I'm drawing a blank.
I'm trying to think what I did. What was my correlation or cause? Like I would think I did the golf one. Oh yeah,
golfing. The golf one. Yes. Golf and mental health, because golf directly does not, it cannot have an impact on mental health, but a lot of the other things that go along with it can. And for the life of me, cannot remember the third one. But I was very pleased with what all 3 of you came up with. I'm going to apologize. I'm going to have some cough, some lemon drops, because I still haven't gotten rid of this nasty cough yet. As long as I don't talk, it's fine. All right. What I'm going to do, I noticed, and it was totally my fault, I forgot to change some of my notes. The difference between the last textbook and this textbook, other than updating and making sure that things are a little bit more relevant, but the biggest difference is they cut out some junk that they didn't need, and they inserted chapter 2, which was on Excel. So my notes were a little bit off that I was having. We actually talked about chapter 6 last week, and it's on our list to be talking about this week.
Yes.
Well, we actually did talk about it before I left.
We did, yeah.
Because that was on correlation.
Yeah.
So you guys did good. What I want to do is what we normally do in, excuse me, is do a review. So I'm going to quiz you a little bit. You get to be picked on because you're the only one here.
Oh, I am? Awesome.
I think Elise is still in Did she just get back or she's still in Mexico?
Oh, okay.
I can't remember. And Christine called and talked to me today. Do you remember the difference between mean, median, mode?
Yes, so mean is the average, take all the mean is you add them all up and then you divide them by how many, and that's the average, the mean. Or they're all average, but that's the mean. Medium is just directly right in the middle. And the mode is the one that's more, most popular,
Good. What one do we use the most often?
the mean.
Okay. What's a range?
The range is just, I mean, I don't want to say just like the range of numbers, but like how many numbers that you have or whatever that you have, the topmost to the bottommost or from
Yep.
one end to the other.
Exactly. So the
Eight.
top, the highest and the lowest. Good.
Yeah.
What's the difference between a sample and a population?
The population is the whole, and the sample is just a little part of the population, a little sample of it or a little part of it.
What's important about a sample? What's important about the relationship between the sample and the population?
I don't know, I'm drawing a blank.
Sample must be representative of the population.
Gotcha. And of course, I left all my notes at home.
No, that's fine. And that's why we review, just so we can
Yeah.
kind of get it. But if you think about it, if your population is anybody who's had cancer, but you happen to work in a women's center and the only people you're going to see are women, then you're not going to get a good sample of your population. If you're talking about something very broad spectrum. So you want to make sure if you're looking, if I'm looking at all students, but I only pick 2 or 3 majors because they're the ones that happen to be handy. In a major university, that would not be a good sample. If I pick nursing students, it would be good if I had a good mix of race, ethnicity, and sex. But to be honest with you, the depending on how big your sample is, you may or may not need a man in there, because men are only 10% of the population of nursing students. In some places, it's less than that. Does that make sense?
Yeah. Okay. I'm just gonna, I do so good and I remember it for the moment, and then when you don't use it, just like anything else, you forget about it.
Did you read what frequency distributions were?
So I did remember touching base on that. I'm drawing a blank of what it is, but I remember reading about it.
How often something happens and tracking it through different people,
Okay.
different levels. We may do frequency distributions on different things of falls, sepsis, other kinds of in-house infections, morbidity rates.
Mm-hmm.
Those are all kinds of things that we can do distributions on. Frequency distribution is how often does it happen, and can you categorize it? Does it happen different ways? It's just how you can categorize it.
Okay.
We talked about graphs. You guys did some very good graphs, and I want to, if you don't mind, I'm going to show a couple of the graphs off, because you guys did a really good job, and I want to make sure that I have a lousy graph on there on that assignment for a reason. Hard to believe, but there is method to my madness. All right, if I go back to assignment 2. All right, let's look at yours. Helps if I go in the right place. Here, let's look at yours. You don't mind that yours is being recorded, do you?
No, not at all.
Okay. This is a terrible graph. It has nothing to do with you. I did this on purpose. Why is that a terrible graph?
I mean, I just feel like it's so much to look at and understand.
Exactly.
Like there's so much color and so much information,
Exactly.
it's not,
It's just overwhelming.
yeah.
So while graphs are very good pictorials of data, they can be overwhelming if we put too much information in them. We could have easily decided we wanted to see 1 week of a certain class, or we wanted to see 1 day of the week and compare the days of the week, or some other way of just of looking at it. But when you put it all here, and all of yours look the same, they just may have gone different directions, but they all pretty much look the same. But it's not good.
Yeah.
Does that make sense?
Yeah, no, for sure.
Okay. I loved the race ethnicity. Some people put actual tags on there, and I have no problem. A lot of times it's nice to have tags that says what this percentage actually is. But when you have really slim slices, that gets a little hard. There is a way to erase them in Excel, but let's not get into the details. All I want you to be able to do is know that you can do a pie chart, and we can help you fix things later if you need to.
But can't you, like on the pie chart, weren't you able to hover over it, the color, and then the percentage pops up?
Yeah, you can't right now because I'm not in Excel.
Right, gotcha, okay.
I'm actually in Canvas and it's not doing it, but you're right, it can. But if you're putting it on a display in a PowerPoint,
You're not gonna be able to do
that won't
that.
help you.
Okay, makes
So,
sense.
Again, it depends. You got to know your audience and know where you're presenting it. If you're doing it for a poster presentation for some scholarship symposium that you're having, you want to have the information available, whether it's a grid over here or arrows, or you take the labels off the little ones, but you leave them on the big ones. Okay. And then this was a bar chart. Everybody did it, whether it was done this way or done the other way, but everybody pretty much did them the same way. You guys all did a wonderful job on that. Let's talk about the answers to the material for a minute. Everybody got that right. That was very good. And it's a decent correlation. It's not the best, but it's not terrible either. So I would agree with that one. And you guys all answered that. Just because one doesn't mean the other, they could go up and down at the same time. It wouldn't make any difference. Now I'm going to ask you a question before we go any further. When you have a positive correlation, what does that mean?
That they're both going up together?
They either both go up or
they
both go down. A negative correlation?
They go in the opposite directions.
Exactly right. Very good. So down here, we did have both. And you have to be careful because my old eyes, my first time I glance at this, I always want to see 0.55 and it's 0.05. That means there's not a whole lot of correlation at all. That's really close to 0.
Right.
This is a negative, pretty close to 0. This is kind of a correlation, but not much of one. Now, you had said strong, and that's the only reason I marked your point off. You want to resubmit, I'll give you half a point for correcting it, but it's not a big deal.
Okay.
I think you have to get close, and there's a little chart in your textbook.
It's closer to 5.5 is the highest textbook.
And that was 0.38.
Gotcha. Okay, so
that's not really, there's some kind of correlation, but I wouldn't hold my breath on it.
Okay.
Does that make sense?
Yeah.
And then you did very good on this one. I'm going to say this only because I'm recording it and I want to make sure that your classmates get to know. If you see that a word does not fit, I've done these crossword puzzles with enough classes. There's not too many blocks on any of the words. So if it doesn't fit, now all yours did, you're good. But if you get a word that doesn't quite fit, that means it's not the right word. Okay. So week 2 actually went very well. Everybody did a good job. And I think we've hit frequencies, we've hit graphs, we've hit correlations. So we've pretty much covered what you needed from that.
Are you still grading the discussions?
I graded them before I got on.
Okay, my discussions are not graded, it looks like. Just my assignment was graded.
But you could. Now I went out to the grade book and put it in for everybody. Did I not save it? Maybe that's the problem. Let's go back out and find out, because I can take care of it for everybody. Everybody did it. Everybody did good.
Okay.
I'll take care of that at the end.
Yeah, no worries.
I'm gonna
Thank
make
you.
myself a note so I can't forget, and I'll do it before I leave tonight. Week 2 discussion board. Now I'm gonna. Okay, so I thought I did it, but maybe I just forgot to save it or something. I want to start with week 3, and week 3 covers chapter 7, 8, and 9. Don't have a heart attack. It's not that long.
You know, I did start reading most of it, but then when I got, obviously, I didn't understand, I didn't understand it. I was waiting for, the teaching.
Yeah, well, we're going to go over that and talk about it a little bit. And then we're going to work together on this. Since I missed, we're going to get you caught up, but we're going to work together to do that.
Okay.
So what I want to know from you is, were you able to read in chapter 7, I believe? No. Yes. Yep. What's the difference? Let's talk about the difference between reliability and validity. That's an important thing for any research project. And when you're reading research articles, you want to understand that they have tested for reliability and validity. Page 147,
Yep.
It puts it in really simple words. If you look underneath the caption that says reliability, doing it again until you get it right.
Mm-hmm.
Reliability is pretty easy to understand and figure out. It's simply whether a test or whatever measure you use as a tool measures things consistently. So reliability means you're going to, if you repeat the test over and over and over again, you're going to get the same answers. Now, validity, we're going to go just a little bit further into, we'll talk about reliability a little bit more, but I want to hit the validity. Validity is the property, or the assessment tool indicates that it measures what it says it does. What good does it do you to get the same test over and over and over again if it's not giving you what you need? So a test needs to be reliable, that you know that you'll see a lot of times when people are doing research, they may actually be copying someone else's research. They're redoing a research project. I don't mean copying as of plagiarizing, but in repeating a research test. Because would you want to have open heart surgery based on something that was done to one person once?
No, of course not. Yeah.
No, let somebody else be the guinea pig for the first 100 times. Then you'll do it.
Yeah.
So it's normal in healthcare and a lot of other fields that research projects are repeated so that they can see, are they truly reliable? Are you getting the same results every time? But what if it's not measuring what you think it's measuring? That's invalid then.
Okay.
So reliability is based on making sure that you get what you think you're going to get, that you're going to get the same thing over and over and over again. Validity is based on, but are you going to get what you say you're going to get? If what you're measuring isn't giving you the right answer, not meaning that your test results aren't right, but it's not giving you the correct information, that's not helping. So reliability and validity go hand in hand,
Okay.
but they are different. Now the book does go and talks a little bit about different kinds of reliability. It tells you how you can test for it. There's a really nice chart on 149 that kind of takes care of all of the things he talks about with reliability. A lot of times with teachers, they'll have somebody else who's a teacher in that same field review a test so that you get inter-rater reliability. Someone else is looking at making sure that what I'm saying is going to happen for them too, that they're seeing the same thing. And as a test is repeated, you're getting reliability because it's being repeated. But that's your test retest. Every time you retest and you're getting the same answers, that tells you that it's reliable. But what if you're the first person So that's where some of the other ones come in hand. I would like you to know where this chart is. I would like you to understand, page 149.
Mm-hmm.
I would like you to have at least an understanding of that there are different kinds of ways to determine reliability. But I'm not going to be totally paranoid about it either. The main understanding I want you to have, and I will ask every week from here out, is what is reliability and what is validity. That you're able. So it doesn't need to be a real deep understanding. For validity, he has a nice chart on 158. So that in a nutshell is what I want you to take out of chapter 7.
Okay.
Now, chapter 8, I'm going to harp on. You're going to feel like forever, because it's going to be everything we're going to do from now on. Every week, we're going to talk about a hypothesis. Do you remember from your science classes what a hypothesis is?
It's just a guess, like an educated guess.
What you think you're going to come up with, right?
Yeah.
Exactly. For proper research, you have a null hypothesis and a research hypothesis. Your null hypothesis is that whatever you're doing, whatever you're comparing, makes no difference. There's no difference between whatever you're doing and what you had before.
Okay.
There is no difference. Null meaning nothing, right? So
yeah.
No difference. That's how you remember it. The null hypothesis always means there's no difference. Now, your research hypothesis generally is, I'm hoping, that you do want to make a difference, whatever it might be. Let's take, okay, I'm in a research study for, I was in for palbociclib, which is a cancer drug. And their null hypothesis would have been taking that will make no difference in my ability to fight cancer, whatever number they use on that. The research hypothesis for that particular research project was that it would make a difference. Now, I'm not going to say that every time they're opposites. Many times, more times than not, they are. But there may be times, depending on what it is you're testing, you might want the null hypothesis to be what your research hypothesis. If I'm in a competitor, I may not want there to be a difference. So the null hypothesis might be my research hypothesis just because I'm being mean and nasty. It just depends on your point of view and how you're looking at it. Your research hypothesis is what you would, if somebody wants to know what's your project about, that's your research hypothesis. Your null hypothesis is always that there's no effect. There's no difference. And the reason is all the formulas are set up so that you decide whether the end number that you get tells you whether there's a difference or not. So we're always looking to decide whether we're going to reject the null hypothesis or whether we're going to accept the null hypothesis. We are never proving a research hypothesis in strict research terms. We may all want to believe that. We want to believe that the anastrozole that I'm taking is another cancer drug, that is helping me. We all want to believe that, okay? So research has shown that the anastrozole has a positive effect. But if you're doing it in a strict research protocol, and you need to when you're looking at things from a medical point of view. You didn't prove anastrozole would work. The research showed that there's a strong possibility that it would work. We are never 100%. I have a t-shirt someone gave me once that says statistics means never having to say you're 100% certain. And that's you. So you will either accept a null hypothesis or you reject a null hypothesis. Now, in either case, it could be wrong. Maybe you didn't have a big enough sample. Maybe there was an error somewhere along. And we're going to talk about a little bit of those as we go along. But we'll start with a very basic premise. Null hypothesis is whatever you're doing doesn't make a difference. Research hypothesis is whatever I'm trying to prove.
Okay.
Make sense?
Yeah.
Okay. And he does a pretty good job of talking about them. On page, this gets a little bit confusing to people, so I want to spend just a few minutes on it. On page 172 and 173, talks about directional and non-directional hypotheses. A directional, let's talk about the non-directional, that's the one he does first. H1 is your research hypothesis. H0 is your null hypothesis. H sub 0. Okay?
Mm-hmm.
If your research hypothesis is that two things are equal, whatever you're doing now is going to give me the they either are equal or they're not equal. We're looking at the whole thing. Then that's a non-directional. If you can write it out that it's whatever. All right. Palbociclib will make a difference. Palbociclib won't make a difference. That's non-directional. We're just asking a very yes/no question. If I'm looking at something that is, I want to see if I can increase the scores of my students by providing online learning and not just face-to-face learning. That's directional. I'm looking to see only if I can increase. Now, directional. Think in terms of a number line where you have 0 in the middle, negative and positive, right? And if you're only looking at half the results, I'm only looking at stuff that happened on this side. I don't care about what happened over here. That's directional. If it's everything or nothing, that's non-directional.
That makes more sense.
Does that help?
Mm-hmm.
Okay. And the reason I bring this up, and the reason it's important here, directional means it's two-tailed. Excuse me, one-tailed.
Yeah.
And non-directional is two-tailed. Because if you're looking at, go back to that bell curve we talked about, if I'm only looking in half, I'm only looking at one tail. But if I'm looking at the whole thing, I'm looking at two tails.
Yep.
Does that make sense?
Uh-huh. Yeah.
Good.
That's a good example. Yeah.
Okay. All right. Let's see. Some of the things that can cause problems with whether I'm going to reject my null hypothesis or not. There's just so many things that one of the biggest problems with any research project is if you don't have a good sample. Is it your sample's not really reflective of your population? Is it that your sample's not big enough? If sometimes you can't help it. If you have a really rare disease that you're doing research on, there just may not be enough people to statistically do things the way we would like to do them, thank God. But on the other hand, you know, if you're doing a broad cancer, we don't do broad cancer research anymore. Our research is so much more refined because we know there's different kinds of cancers. If you think back when I was a kid, people talked about cancer as one disease. Well, that's not really the case today. So if you're looking at something really, depending on what you're doing. Okay, again, another one, we have found over the years, muscular dystrophy has different forms. Multiple sclerosis have different forms. Originally, when we were doing the research on it, it was such a broad spectrum that we may have gotten sampling errors because we weren't comparing apples to apples. But we didn't know that. It was all muscular dystrophy or multiple sclerosis at the time. We didn't know that there were different forms. As more research has been done, we're finding that we can fine tune what we're looking at. We may find that with, well, gee, we have how many variants of COVID?
Right.
Influenza. Influenza was that nasty thing that we got. Yes, we had the Spanish flu, and then we had the annual, everybody gets the flu thing. And then all of a sudden we started having bird flu and H1N1 and variants. But years ago, we would have just thought it's all flu.
Mhm.
When you're looking at your samples, particularly in healthcare, you got to make sure that your sample is reflective of what you need and reflective of your population. If we were looking at suicides, which is still a medical issue that we have to think about, postpartum depression and suicide. There may be other factors that we have to make sure when we're looking at our sample are not, are we looking at abused women versus women who don't come from an abused background? Are we looking at women who have postpartum depression due to miscarriage or women who went full term? So we may need to, our sample, we could have an error in our sample that could have an input on whether we're going to be able to make a good judgment or not. We may reject or accept our null hypothesis based on what we have, but that doesn't mean the research has to stop. You take a look at it, you say, I know that's right. So what did I do wrong in looking at it? Is there another way I can look at this? My absolute favorite story is Viagra. It was tended to be a heart medicine. It had a side effect nobody expected. So when they were looking at the heart medicine, they didn't have a problem with the women. They had a wonderful side effect for the men.
Mhm.
Then they needed to then split off and do additional research for what they knew they could do with it. And that kind of hits on discussion board that we have for week 4 is some of the medical research and how much money they make off on things that really don't work. All right, so does that kind of explain hypotheses to you?
Mm-hmm. Yeah.
Okay. Okay, we're back to our bell curve. If you look on page 182. Everything we do for my class is based on a normal bell curve. Now, we talked a little bit in that second week about skewed bell curves, but we're going to look at mostly at your normal bell curve. If you look on that particular example, and I don't know why he puts all 3 averages out there because we look at the mean. And then what falls on one side or the other is what helps us determine where we are. if it falls within the bell curve and how far away from the mean is it? And that gives it, we have other figures that can tell us if that's really far away or if that's kind of not so far away. And we're gonna talk about that a little bit. There was my favorite page. Well, look at 184 and 185. There's two here that we will use. You'll refer back to frequently as we do some of our tests. On 184, it's telling you how many what a standard deviation of 10. If your mean is 100 and your standard deviation is 10, then you have one standard deviation on either side. You go up 10 or down 10.
Okay.
Your second standard deviation would be another 10, up 10 or down 10. And your third standard deviation on either side would be up another 10 or down 10. Does that make sense?
Mm-hmm.
So you always start with your mean, and your standard deviations are, if you have a normal bell curve, they're even on both sides. Okay. Hi, Elise, how are you doing?
I'm okay. I have COVID.
Heads up warning, I'm recording us, so you can't yell at me.
I'm not gonna yell at you. I've had COVID. I went to Mexico and got COVID.
You didn't.
I did.
I am so sorry. That is not what you went down there for.
No, but I didn't get it to the end of it, so we're good.
Oh.
Yeah, there's no way to come back to work either.
No. Well, they
That's
won't let me
not
come
fun.
back till Wednesday.
Since I'm recording it, I'm gonna let you catch up later on what we talked about. But if you need something on what we're talking about now, we can stop and go back, okay?
Okay.
We're in page 184 and 185. We're talking about normal bell curves again. And it helps to have a visual, and I think these pages just help us with the visual really well. So let's do it one more time. If we're looking at on page 184, the curve is set up that if your mean is 100 and you have a standard deviation of 10, that means you can go one standard deviation higher would be 110, one standard deviation lower would be 90. If you're looking at the second standard if you're looking at two standard deviations, you would then be at 120 if they were going higher, or 80 if it was going lower. And if we get to three standard deviations, 130 and 70. Now, what's important about a standard deviation? Why is it important that I know what that means? If you look at the chart on 185, it gives you percentages. If you take the one standard deviation, I'm sorry, starting again. Okay. One standard deviation on either side of a mean means you've accounted for 68.26% of your data. In a normal bell curve, one standard deviation on either side of the mean means you've accounted for 68.26% of your data. Then you have another 26 point, I'm sorry, 20, a little over 27% if you add in the next standard deviation on both sides. So if we're looking at the whole curve, you start out with 34% on this side and this side, and then another 13.5% on this side or this side, and then another 2.15%. The whole thing is 99% of your data is reflected, if it's a normal bell curve, 99% of your data is reflected in 3 standard deviations. If it's a normal bell curve, you're not going out very far. Have you guys ever heard of 6 Sigma? It's one of the methods that the ministry uses to do some quality improvement. Sigma is one of the Greek alpha letters, is used to describe standard deviation. 6 standard deviations is 99% of your data. You only, if you can get everything within a decent, get your standard deviations to be close in, so they're very narrow, you've taken care of 99% of your problems, and you've only got less than 1% that's an issue. That is a hard concept to understand. So let's go back and make sure that we understand what the standard deviation, how far it gets you away from the mean, right? But what does it mean if I'm a standard deviation away from the mean? How much of my data does it tell me? If I'm looking for before I say that, let me go back one more thing. I want you to look at page 186. He's got one more chart that I think combines the two and makes it a little bit easier to understand. He shows you the raw scores. He shows you the positive and negative standard deviations up and down, and he shows you the percentages. So it kind of puts it all together. Does that help any? He does a nice job with his charts and with his graphs. He does a really, really good job. If I'm trying to find out if I have certain data, the example I have is from the homework, and we'll go over it. If I'm worried about how many people, I have to word this so I don't confuse myself. All right, let me pull up my homework, because I've got homework is just one I got from one of my old stats classes that I really liked. Let me pull it up. All right, let me see where this will let me show it for you. Okay, so this is a normal, we're going to say this is a normal bell curve, and the yellow space to the left of the curve point to double arrows. So you can see that, all right, this is 34.13%. This is your 68. And if you go up 2 standard deviations all the way out, it's 95.44%. But if I'm only looking at what the difference is between first standard deviation and the second standard deviation, that's 13.9%. If I'm looking the difference between the second standard deviation and the third standard deviation, that's 22.15. The way to remember this is, don't think about how wide this is. Think about everything that's encompassed under this curve, because it's all of this is 68%. All of this is 95. All of this, including all this upstairs, not just down here at the bottom, That's where you get your 99.74. And the stuff out here just ends up being a little bit of nothing. So think of it as the total area of the entire curve, not just this line. Because if you're looking just at your standard deviation, it can be very confusing. You're saying, well, that's even, and that's even, and that's even. But this isn't. So the area on this amount is very different than the area on this amount. Does that help? Okay. So here's my favorite example, because like I said, I swiped it from somebody else. The mean speed of vehicles, that would be whatever's here, is 56 miles an hour. And the standard deviation is 4. So if this is 56 instead of 100, this is 56. What would this be if the standard deviation is 4?
Um, 52.
We're going positive.
Okay, so 56, 60, 60.
60. And what would be the next one?
64 if it's going by 4s, then, right?
Yep.
64.
And then the next one?
68.
Yep. And if I start here at 56, what would this one be?
52.
Yep.
You do some math here. 52, 50, 48.
Yep.
44.
Very good.
Okay.
So you start with your mean, and your standard deviation tells you how much to go up for each unit that you're going up.
Gotcha. Okay.
And it tells you how many go down for each unit that you're going down.
Okay.
Okay. Ignore what this question is, because it's for another part of your assignment. It's for later after we get to a test. But what it's saying is, if I wanted to know what 68% of the people are doing, what speed are they going? It's going to be between here, isn't it? They're going between 52 and 60. Well, that's all right if that's on 20 outside of town. But if that's on 20 right by the hospital, you don't want them going that fast. Does that make sense? So this is telling you we're only looking at this part of it as what if we have a mean and we know what the standard deviation. The standard deviation just says how far you are away from the mean and how much between those two, between the mean and how much of your data is based on that if it's a normal bell curve. Now, that's where it becomes very important that we discuss that things are based on a normal bell curve. Because if you remember some of those pictures of skewed curves, if it was actually over here somewhere and going like that, then it doesn't work right. So everything we're talking about is based on a normal bell curve. You have just as much on the left side as you do on the right. They are mirrors of each other.
On this normal bell curve, the percentages will always be the same.
Yep.
Okay.
Whatever the percentage here, if you're only looking at one side versus the other, we talked about one tail and two tail. One tail is we're only looking at one side.
Right.
Two tails, we're looking at both sides. If we're only looking at one tail, then we want it to add up to 50%. If we're looking at two-tailed, we want it to add up to 100%.
Okay.
Does that make sense?
Yeah.
Okay. All right, let's see. He has a couple of examples, and then we start talking about z-scores. A z-score, where does he first bring it?
Is it 188?
Yeah. Well, he gives a nice lengthy discussion on what it means mathematically. But if you look at where it first says standard scores in blue, these are scores that are comparable because they are standardized in units and standard deviations. So what it amounts to is we're gonna do a Z-score is gonna tell us how many standard deviations we are away from the mean. So if you have data using the formula, you can figure out how far away from the mean you are. What I did is these are the Z-scores. So approximately what percentage of the cars are going faster given the speed. So if you have a Z-score of 1.5, and you're doing guesstimate because it's not exact. So if we have somebody doing 62 miles an hour, so we said 60's here, 62's right here, right? Right in the middle. So if we split this in half, and we know that from here to here is 34%. And from here all the way over to here is another 13.5, 13.6%. But we're not going to get all of it. We're going to get a little more than half of it. So eyeballing it, I'm not asking you to do any more than that. Eyeball it. How much do you think? How much? What percentage of the cars that were tested fall between the mean and 62 miles an hour?
So you're taking the 68%. So I
We're
would
only
say,
looking at half.
oh, okay.
This is a one-sided. We're only looking at what's higher. We're not looking at what's both.
So 34 plus.
Yeah, I would say.
15. I mean, well, plus 7.
Yeah,
Okay.
I would say plus 7.
37, 34. Like 42.
Yeah, 41, 42%.
Yeah.
Fits right there.
Okay.
All right. How many were driving? Okay, now I'm going to reread the question. Approximately at what percent of the cars going faster at each given speed? What I asked you was how many were going between the mean 56 and 62. Now, how many were going faster than 62?
So I would do half of that, half of the 13, which was the 7, and then add the 2, 8,
Yep.
9, like 9.5, 10.
Yeah. An easy way, you figured out what was the other one?
What do we say, 14?
You said 40, 41, 42.
Oh, yeah,
Well,
42.
if we know that this is 50,
True.
from here to here is 50, and we're only going from here to here.
Like 25.
So from here to here is 42. And 42 from 50s, 8, roughly. So it'd be
Yeah.
about 7, 8, 9%, depending on how close you were getting on splitting hairs. Does that make sense? Because we're looking at actually who's going faster. And if we're looking at who's going faster, we're only looking at this half on this particular question right here.
Okay.
Elise, have I lost you or have I got you?
I'm lost.
Okay.
I'm
Do you
sorry.
understand where we got where the standard deviations fall in?
Yes.
Okay. And do you understand that if we change these to 56, our mean here, that this woman then becomes 60 because it was standard deviation of 4. Does that make sense?
Yes.
Okay. If I want to know what percent of the drivers are at 62% driving faster than 62 miles an hour, and we know 62 has a Z-score of 1.5, so we know it's out 1.5 standard deviations. And I don't want to really know what this part is, but it was a really nice start because if I know that from here to here is 50%,
Mm-hmm.
And if I take from here to here, and we knew that was 42, we subtract that from 50, we know that this is about 8%.
Okay.
Does that make sense?
Yeah.
Okay. The other way was the way to do, the way we talked about the first time. Jennifer said, if we went from here and just this, we said that the whole thing is 13 and a half, little 13.6. So we'll guess, 7, 8, somewhere in there. And then add the 2.15. So we're looking at 8, 9%. That's round enough for me either way. You can either add up from where you start all the way through, or you can figure out whether you're doing 50% or 100% and subtract out what you're not using. If you think about what you're going to color, if you were to color in what we're talking about, I want to know higher than 62 miles an hour. So if I put a little dot there and then I colored in this part, this is what I want to know.
Mm-hmm.
Then I know what I have to add up. Let's go to the next one. It's a tougher one. I want to know how many people are going faster than 47 miles an hour. Now, we said this is 50. This is
46.
Oh, we said this is 56. I'm sorry, my fault.
Oh yeah, 56.
So this is 52. This is 48. So about a quarter of this one. And we want to know faster than, right? So I want to know from here up
All the way across.
all the way over. That's a lot,
That
right?
would be 99 minus.
Like that 0.13 and the half of 2.
Yeah.
Like maybe even just like minus 3.
Yep. You're looking at 97, 98%, somewhere in there.
Okay.
Exactly right. You guys got it now. Now, how many people are going at least 56 miles an hour?
Would just
What's
be,
our mean?
your mean is 56.
So how many people are going at least 56 miles an hour?
Half.
Half.
Yeah.
Exactly. If you have a z-score of 0, that means you're right at the mean. And if it's a normal bell curve, half of them are going faster and half of them are going slower.
So the standard deviations on these represent the Z
No.
score?
There's a formula for taking standard deviations for figuring out the z-score. A z-score tells you how many standard deviations you're off. Z-score is looking at what you're looking at and your mean and telling you how many standard deviations you are away from the mean based on this. And that's what his a Z equals what your raw score is minus your mean divided by your standard deviation. So let's do it mathematically once. I'm gonna get my calculator out because I can't do this with the computer and everything else going on. So let me find my calculator. I had it here earlier. Okay. So, because I don't do math in my head, I make mistakes. If we look at 62 and we subtract 56, that's our 62 is our raw score that we're talking about. 56 is our mean. And divide it by our standard deviation, which is what?
4.
4 is 1.5. So I know that 62 is 1.5 standard deviations from the mean. So we're looking at the raw score. And how do I know how far that is away? That's what this is saying. A z-score says, okay, if I'm looking at my nice pretty bell curve and I know this is 56, and I know that it's more complicated if you have really big numbers. If this is 56 and this is 60,
There's 4.
60 for the first one, 64 for the second one. So where does 62 fall in? If it wasn't so obvious, it falls 1.5.
Okay.
If you had numbers that were a little more difficult to add and subtract, it would be more helpful. This is a little obvious because we want to keep it simple and not get real complicated. Let's do the other one though. Let's look at 47. If we have 47 and we subtract 56, that's what our formula says on 188. And then we divide it by 10. Excuse me, not by 10. We divide it by 4. Because our 47 is our raw score, 56 is our mean, and we divide it by the standard deviation. And that gives us a negative 2.25. So that means that I need to go out 2.25 standard deviations to find where 47 is. Now, if I was to ask you, looking at this 2.25 here, right there, how many people were going slower? What would you say?
It would be like 3.
Yeah, it'd be less than 3.
Less than 3.
Yep. Yeah, probably be close to right around 2. Yeah. Because we'd be only looking from here to here.
Split the 2.1 and 5 in half, yeah, or,
Well, we only want 3/4 of it.
yeah.
A quarter or 3/4, depending on where you're looking. Yeah. You've got the right idea. Elise, have I totally lost you or are you okay?
No, I'm okay.
So that is a Z-score. A nasty little thing. I'm not going to ask you that. That's the only time I'm going to ask you to do a lot of hand calculations is that exercise right there. And we just did it together. So, and you can pass it on to Christine if you see her. She will have access to seeing this as well. So that piece of your homework assignment just got done. All right.
Too bad I didn't
Can
write
we
down.
take a quick break so I can refresh my? Can we
Yeah.
get back in 10 minutes?
Yeah.
Okay, thanks.